All of the information embedded in the first 5 videos is remembered by this outside containment field. Natural modular building techniques uses containers to demonstrate the interconnectedness of geometrical systems in basic geometry. There are structural and numerical constants that regulate how each one of these fit inside the other. This geometrical system is called a rhombic dodecahedron, where rhombic means diamond-shaped, and do equals 2 and deca equals 10. This is a 12-sided diamond-shaped structure that has all of the self-organizing abilities that a sphere has. We will call it an r.dodeca. It has a sibling that Buckminster Fuller called the coupler. There is a variety of ways these two systems interconnect. In one method, there is always a half-size r.dodeca inside any coupler. On the 4 sides of an r.dodeca, 4 half-couplers are placed to define the bigger coupler. Another method is to divide the volume of an r.dodeca into 6 equal modular units. Each will be a half-size coupler. We will see the coupler and the different ways you can divide it in half literally couples many systems together. The r.dodeca is made up of 12 sphere diamonds, where both the square root of 2 and the square root of 3 build the shapes. A diamond has 4 equal sides with a long and short axis inside. The relationship between these two will always be relative to the square root of 2. Half of the short axis multiplied by the square root of 3 will define the outside length. The coupler is an asymmetrical octahedron, meaning the system has 8 sides, which each side being a half-sphere diamond. The equator of the coupler divides its edge into 1/3, 2/3 segments. The orientation of this coupler is defined by our all-purpose axis of spin that all structures share. There is a deeper connection that the r.dodeca coupler has with the closest packing of spheres. It organizes the connections between the spheres into modular units. The space between the spheres of the first layer is an r.dodeca whose long axis is always double the diameter of the spheres, or 4 times the radius. This half division of the outside corner spheres holds true on all the layers. Here at the center of the 12 BB long axis diamond shape is the outside corner sphere of the 3rd layer divided in half. Variety of options is how design in nature's whole systems thinking works. After organizing the space between, you can contain each sphere individually. Here the long axis of these sphere diamonds are 2 BB equals 4 centimeters. Or you can build out a first layer around our initial 6 BB limit, creating a future growth grid that defines the relativity of the spheres to the other fundamental structures. The 6BV VE contains a 6 BB long axis rhombic dodecahedron inside it, which is the same size as the other 12 closest packed around it. When stacked together, the rhombic dodecahedron fills up all of the space without gaps between. It is an all-space filling system. It is also an example of the closest packed state. The interconnectedness of the parts make it a very useful synergetic whole. The last example of this synergetic relationship is the half coupler that defines the space between the spheres of the first layer. What connected the center to the outside corners of the first r.dodeca can be turned inside out to define the outside spheres of the second layer. Synergy is the idea that everything is connected to everything else and is the glue that holds design and nature together into fundamental communication networks that connect its essential parts.